So we are going to finish 1.7 notes today. You hopefully have the handout that I posted last time with the first part of these notes. So what we have done up to this point is we have solved, well, we've worked on interval notation and solved inequalities. Most of this, I think, is stuff you've seen before, and I hope you've also seen this before, but this is always this can be kind of confusing as to why these rules that you see in front of you are what they are. So I'm going to try to put it into a context that you understand. So let me explain these rules. It says that if x is an algebraic expression, and notice they're using a capital X. What they're using capital X to represent is something like 3x plus 4 or x minus 2. So inside the absolute value bars, you're going to have a statement that looks similar to like 3x plus 4 or x over 2 minus 6, anything like that. So x represents that algebraic expression that's in the absolute value bars, and c is a positive number. Notice the positive, we can't have a negative with absolute value because absolute values never equal a negative. So if you look at this first statement here under the general description, the solutions of the absolute value of x, this is that algebraic expression like 3x plus 4, is less than c are the numbers that satisfy negative c is less than x is less than c. That's weird. Okay, so let's put this into much simpler context. I'm going to make my algebraic expression little x. And this says less than, so I'm going to make it less than. I'm going to actually pick a number c. Let's pick 2. 2 is really easy. So if you remember back to when we talked about absolute value equations, we actually had two solutions. We'd set x, if this were an equal sign, we'd set x equal to 2 and x equal to negative 2. So it's kind of the same idea, except it's not just equal to those numbers, it's actually a range of numbers, so it's an inequality. So knowing that this could be 2 or negative 2 to make it equal, even though this doesn't have an equal, we're going to consider negative 2 into our boundaries. But because this isn't equal here, I'm going to use open circles instead of closed circles. Okay, so if I continue to work with this and I think about what numbers are actually going to make this absolute value inequality true, I'm going to test in each region. So this negative 2 and 2 splits my number line into 3 regions. So if I test in this region, I need a number less than negative 2, so let's use negative 3. And let's think about the absolute value of negative 3 is less than 2. If we find the absolute value of negative 3, it's actually 3. And is 3 less than 2? That's a false statement, so we don't shade where it's false. We leave that open. That's not part of the answer. So let's put 0 in. If the absolute value of 0 is less than 2, then that's just 0 is less than 2, and that's always true. And so what we find out is when one number is true, all the numbers in that region are true. So I'm going to shade in between negative 2 and 2. Now I'm going to test a number outside. So I'm going to test 3 and see if 3 makes this true. So absolute value of 3 is less than 2. Is 3 less than 2? Absolutely not. So this part's false. So what we see here is a statement that says negative 2 is less than x is less than 2. If you look at that, that is how we write that as an inequality. Now, notice that this is in the same form as this. Now, all of a sudden, this is in the same form as this. Okay, so what this statement is saying is now, since we know this is true, if I have the absolute value of x plus 3 is less than 5, to solve this, I can rewrite it as negative 5 is less than x plus 3 is less than 5. Now we know how to solve these because we did compounds in the last set of homework. So what we would do, I'm not going to finish this, but what we would do is we go ahead and solve this to get the solution. This is why, this is what we actually do. Okay, let's see the why of this one. This one's different because it's the absolute value of x is greater than c. Last time we did less than, now we're doing greater than. So this isn't jammed together like this one was jammed together. This one has an or statement, and so this one looks a little different. So let's look at what that looks like on the number line. So I'm going to use 2 again, where absolute value of x is greater than 2. I'm going to go ahead and put 2 and negative 2 on my number line, and I'm going to use open circles. And I'm going to test numbers. We'll test negative 3, 0, and 3. I'm just picking the same ones because we're used to seeing it. You could use -5, -100, you could use -1, you could use 15 here. It doesn't matter. Okay, if I put the absolute value of -3, I get 3 is greater than 2. That's true. So when it's true, we shade in that region. When I put 0 in, absolute value of 0 is greater than 2. 0 is greater than 2. That's false, and so I don't shade here. If I test 3, is the absolute value of 3 greater than 2? Is 3 greater than 2? Yes, this is true, so we shade in this region. And so what we find is I have two inequalities. This one right here is x is less than -2, but I also have x from this region here, x is greater than 2. And since both of those could be true, we say the solution could be less than -2 or it could be greater than 2. And so that's where this statement comes from. X is less than the negative version. Notice less than goes with the negative, greater than goes with the positive. Oh, that always helps me remember less than is negative, greater than is positive. That's only if it's a greater than. Okay, so what that tells me then, and I'm going to have to erase some of my stuff here. Ooh, I need a bigger eraser because that's going to take a little bit. What that information tells me is then if I give you an absolute value greater than, so x plus 6 is greater than, absolute value is greater than 7, by this rule, because it's greater than a positive number, I break it into two pieces. X plus 6 is less than the -7, or x plus 6 is greater than the positive 7. Less than goes with negative, greater than goes with positive. For the less than, I just know that I crunch it together. I just have memorized that. And this is something you will have to memorize. These rules are valid even if I have an equal to on it. The only difference is the circles will be filled in, and we'll use brackets instead of parentheses when we talk about interval notation. Okay, so I'm going to go to the next slide. I'm going to write the rules at the top, and I'm going to do two problems with you. So the first one, solve each absolute value inequality. Well, the first thing I'm going to look at, it's absolute value and it's less than, so I need to go back. What's my less than rule? Oh, it's this one. So I need to write it like this. So let me write it out. If I have, whoops, I went the wrong way. If I have the absolute value of x is less than c, then I write it -c is less than x is less than c. In this case, c is 5, so it's -5 is less than x minus 2. Notice the x minus 2 is in x's place, so when the x is here, I'm going to write x minus 2. Then I got to do less than again, and I'm going to put my +5. Okay. Now I have a compound inequality, which we worked on yesterday. I'm just going to solve by getting x by itself in the middle. So it's -3 is less than x is less than 7. Of course, I want to see interval notation. So if you need to see that number line, you see it here. We know that's shaded in between. It's parenthesis -3 to 7 parenthesis. Okay. Next question is this one. Oops. We're at a greater than, and so the greater than rule is negative, let me write it out. X is greater than c, so it's x is less than -c or x is greater than c. So we do this by equating x to 2x plus 3. So here, instead of x, I'm going to write 2x plus 3 is less than, there's 5. Ooh, that's an equal to. When that's an equal to, I need to put an equal to on these. So 5, and instead of writing -c, I'm going to write -5, or the x's equivalence is 2x plus 3. Now we're going to do greater than or equal to, because of that equal to, 5 corresponds with c. We have two separate equations or inequalities to solve. So what I'm going to do is I'm going to subtract 3. 2x is less than or equal to -8. Divide by 2. X is less than or equal to -4. I'm going to keep bringing this or down here because that's important, and I'll explain why in a minute. Here I'm going to subtract 3. 2x is greater than or equal to 2. Divide by 2. divided by 2, I get x is greater than or equal to 1. So let's see what this looks like on a number line. Here's negative 4. That's equal to, so I'm going to do a closed circle, and it's shaded to the left because it's less than or equal to negative 4. Here I'm going to put 1. It's a closed circle. I'm going to shade it to the right. Okay? Because this is an OR statement, I need to write an interval notation statement that includes both of those in it. So the way this works is I write the interval notation for this. And of course I'm going to put a bracket around 4. Instead of writing OR, I'm going to use what's called a union symbol. It looks like a capital U. And then I'm going to write this interval notation, 1, bracket 1 to infinity. And so this replaces the OR statement. In inequality ways, that when we present our answer as an inequality, we write OR, but when we write it in interval notation, we use the big U. That's pretty much all the examples I have. It's just a matter of practicing. So we'll see at the beginning of class if we need to do more examples or if we want to try some activities. We'll just kind of see how it goes. I do have a bad joke. I actually have a few, so I can't decide, but I'll do this one. What did one shark say to the other while eating a clownfish? This tastes funny. This is Mrs. Lauer signing off. You guys have a great day.